All right, we're back. Part 2 of section 12.5, the normal curve. This is Dr. Kellogg, and we are making progress. All right, so I left you with a formula for finding the z-score for any data value. Every data value has a z-score, okay? And let's first just practice finding z-scores, and then I'll show you how we use them. All right, so SAT tests. SAT is one of the most standardized data items there is. That's why they want to hold their security so tightly so that it maintains their standardization and the reliability and the behind the SAT and the ACT. All right, so let's go with the information that it has a mean of 500 and a standard deviation of 100. Now, I know that's a big standard deviation because that's SAT scores are all over the place, right? All right, so let's just calculate z-scores for these different data items. And I want you to be looking for patterns. Hopefully you'll anticipate some different things about these z-scores as we get going. So let me remind you. So I'll write it out the first time, okay? So the z-score is the data minus the mean over standard deviation. Okay, so in this case, the data item is 600, and the mean is 500, and the standard deviation is 100. So you're going to get 100 divided by 100, or 1. Well, that kind of makes sense, because if the standard deviation is 100, how far above 600, how far above 500 is 600? 1 standard deviation, 100. Okay, and it was positive because 600 is above 500. Okay, all right, z-score for 350, and that's a good way to write it, z 350 down in the subscript. So it's going to be, is this going to be positive or negative? Well, it should be negative, right? Because 350 is below the mean. Okay? So grab your calculator. 350 minus 500 is negative 150. Divided by 100 is negative 1.5. That tells you that the z-score, that the score of 350 on the SAT is 1.5 standard deviations below the mean because it's negative, below. Okay? All right. You guys do this next one. All right, I'll give you a head start. Go ahead and set it up. 770. Go ahead and you start working your notes and don't even look at the video. When you come back and look at it, I'll have it all worked out for you. Did you get 2.7? Well, yeah, 770, that's a good score. So you're almost 3 standard deviations above the mean. And remember what I said, 3 standard deviations above the mean? Okay? Remember? That's way up there. That's way up there. Almost nobody is above you. Okay? You're going to get into any school you want. You're way up here. Way up there. Okay? Okay. And the last one, a score of 500. What will the z-score be for that? Come on, what's it going to be? It's going to be 0, right? Because 500 is the mean. It's not above or below the mean. It is the mean. So you do the data item minus the mean, and you get 0 over 100. Right, that makes perfect sense, right? Okay, all right. So we don't ever report z-scores on documents. Like when you got your SAT, you didn't know anything about a z-score. It just said you were in the 39th percentile or the 48th percentile or the 65th percentile, right? Right. We use percentiles because a percent is out of 100. A little bit easier for people to understand. Like, 0 is bad, 100 is good. I'm at a 68, so that's better than 68% of the people. I guess that's pretty good. All right, so that's how we take the z-scores. Now, there's a way to convert every z-score to a percent. Every data item has a z-score. Every z-score has a percentile rank to it. Okay, so if you want to get used to doing this, okay, you can sketch a little diagram of the normal curve. Okay, sometimes we'll do that just so you can see where the data items are falling. We can use a formula to convert the given data to a z-score. We already have that one, right? That's the data minus the mean divided by standard deviation. Right. Okay. And then simply look it up, okay, on the table. And again, it's called 12.8 in your book, but I emailed it to you, and I think I had to trim it so that it doesn't say 12.8. But print it out, and it'll look just like this. Okay? This is a little hard to see. Oh, good. I can zoom in. Super cool. Okay. So let me just point out a few things to you. Okay. So notice it starts over here with whoops. Try again. With negative z-scores. And the positive z-scores are over here. Okay. And in between negative 3.3 and 3.4, it's broken up into 10 increments. It actually goes by tenths. So let me just pick one here. So if a z-score is negative 3.32, okay? So you go negative 3.32, and here's the 0.2. So it's right here. Negative 3.32 right here. Okay? 3.3 and then the 0.2. So you have the tenths and the hundredths. For the hundredths place, you look across the top. The tenths is given to you in the table. Okay? So you'll get really good at this. And we'll just look these up, and from that I'll talk to you about what that means. Okay? All right, so this is our table. All right, here we go. Let's just get used to finding the percentages that go with a z-score. And we're going to work with IQs, something different. So IQs have a mean of 100 and a standard deviation of 15. All right? They have to give you that. Always look for that in the homework. They've got to give you the mean and the standard deviation. Okay? So find the area. Now remember, I told you they're going to interchange area with percents. It means area is a percent of the data. Okay? An amount, a percent. Same idea. Okay? Find the area under the standard normal distribution, which means find the percentage of IQs to the left of a z-score of negative 1.2. Okay, so in this case, they didn't give you an IQ. They actually gave you the z-score. They already did the work for you. We just want to look it up. And it says to the left. That's going to be really important. Okay, really important. All right, so negative 1.2, here we go. Negative 1.2. Negative 1.2. All right, here's negative 1. Whoops. Oh, that makes my pen huge. Oh, stink. We'll see if we can figure this out. Okay, so negative 1.2. So negative 1.2 is right here. And if you look closely, that's the 0. In other words, that is the one we want, the one right next to it, because that is the, so negative 1.2 is right here. I'll show you. Negative 1.2. This is negative 1.2. Okay? That's negative 1.20, which is the same as negative 1.2. So 0.1151. 0.1151. Okay? So 0.1151. So remember that's a percent. So that's 11.51%. Just move the decimal 2 places to the right. So let's write the percent down. Where'd it go? So, whoops. Okay. It was 0.1151 or 11.51%. Okay? Now, the way that we read this table, always, the percentages off this are by default the percent below. Okay, so anytime you read the table, it's percent below by default, always. So we pulled off 11.51 from the table. Okay. And I'm just looking for my slide here. Oh, I got the table multiple times. Okay, all right. So 11.51% below. Okay, that's just the way you read the table. They had to set it up one way or the other, and they set it up as below. Okay. To the left of the number is below. Think of a number line. So the percent we got from the table was 11.51. Okay, 0.1151 is 11.51%, and that is below. Okay, so if your IQ had a z-score of negative 1.2, then that means there is 11.51% of the people have an IQ below that. Okay, if you pull the number off the chart, you ought to always say below. Okay, let's keep practicing. So here's another way. Find the area or find the percent to the left or below. To the left or below means the same thing, of an IQ of 122. So if that's your IQ, let's first find the z-score. We have to find the z-score first before we can look it up. Okay, so I need a z-score for 122. And it's always the data item minus the mean, which is 100. They gave us that up above, right? Over the standard deviation of 15. Now, should this be positive or negative? Well, 122, is that above 100 or below 100? It's above, so it's going to have a positive z-score. Remember, a z-score is just how many standard deviations above the mean. That's all that is. Okay? How many standard deviations above the mean? So 22 divided by 15. 1.46 or 1.5. Round it to the nearest tenth. Okay? So 1.5 is the z-score. So 122 is 1.5 standard deviations above the mean. That's pretty good. Okay? Let's go find out what percent of the people of the population have an IQ below that. Notice how I said below right off the bat, because that's what the table gives us. So 1.5. There's 1.5, and right here is 1.50. It didn't have a tenth, just 1.5, so 1.50, 0.9332, or 93%. Okay? 93%. So that is equivalent to saying 93% are below. I mean, I can turn it around and I can say, oh, so 7% are above? Yeah, but the table doesn't give that. The table always gives you below. Okay? So the table tells you 93% of the population are below this person's IQ of 122, which means they're 7% above. So you can kind of go either way, right? Once you know the one, you can figure out the other. Okay. Now, if I know how many people were in a certain testing site or in a certain class or in a certain group, then I can actually tell you how many would be above or below that score. Okay, so check it out. Say they opened it up for an IQ test and 300 people showed up. So if 300 people took the IQ test, how many, not what percent, how many will be expected to score below, keywords, okay, below 122? Well, we just did that, and we just found out that from the table, we looked up the 1.5, and we got 93%. So what is 300 times 93%? Now, depending on your calculator, you may actually have to go 300 times, whoops, because what's 93% as a decimal? .93, right? So go ahead and multiply 300. 300 times 0.93, you get 279. 279 people would score below that. You could predict it. Now, you might be off by a little bit, but you're going to be pretty close because IQs are normally distributed, and normally distributed data behaves. Okay? So what if it wanted to say, what if it asked for, hey, how many people will test above that 122? Well, if 93% are below, then 7% are above, right? So 300 times 0.07, or the difference, right? What's 300 minus 79 to be the other 21 people, right? So 300 times 0.07, and you get 21. Okay? So remember, below is what comes off the table. Okay? Okay. Study this sheet here. Now let's take a look at data to the right, or above, or greater than. Okay? We just got done doing to the left, or below, or lower than. Now let's take a look at how we would figure out data to the right, or above. Okay? So here's a nice picture to help you with this. Okay? It says when finding the percent of data to the right of the or above the z-score, just subtract it from 100. Well, that's what we just did here, right? If 93% was below, which we got from the table, then what's left? 7% would be above. It has to add up to 100, right? Okay? So when you find your z-score, when you look it up on the table, it will always tell you the percent below. Well, all of this is 100. So if I want up here, then it will just be all of it minus the yellow. So it'll be 100% minus the below. Will give you the above. I hope that makes sense, right? 100% minus the below will give you the above. It's got to add up to 100. And remember, the below part always comes off the chart. The table always gives you below. Don't forget that. So if they ask for below or left of, just take what the table gives you. If they want above or to the right of, you've got to subtract it from 100. Subtract the table, what you got from the table, from the chart, from 100. Okay? Okay. Let's go back to IQs. Remember, mean of 100, they've got to tell you that, and a standard deviation of 15. Okay? Use the table to find the area, okay, to the right or above. To the right or above a z-score of 0.45. Okay, well, z-score of 0.45, let's go look that up, 0.45. So grab yourself your table. They already gave us the z-score. We don't have to find it. Okay, 0.45, 0.45, 0.45. Well, there's 0.4. Okay, right here is 0.4. and 0.4, and look under the 0.5, it'll be right here. Okay, 0.6736 or 67%. Just kind of round it, okay? 67%. Okay, so let's go back to our problem. So we found that this gives us 67% what? Above or below? Below, right? Because we got it off the table. We got it off the table. So if we want the percent above, how are we going to do that again? How do we do it? Subtract it from 100, right? It's the other piece of the pie, okay? So the above equals 100 minus the 67, which is 33%. And if you add that up, it better be 100. It better be 100. Okay? All right, let's do one more, and then I've got to stop the video because it's going to get too long, and then we'll do one more. Okay? To the right of an IQ of 84, find the percent or the area that's to the right of an IQ of 84. All right, well, what's the first thing we always have to do if we're going to try to find percents? We have to find the z-score first, right? So z-score of 84. Now 84, that's below 100, right? So our z-score should be what? Should be negative, that's right. 84 item minus the mean divided by the standard deviation. Grab the calculator. Negative 1.07. Negative 1.07. Okay? Let's go look that up. Let's go look that up. Negative 1.07. So negative 1, negative 1, negative 1. Oh, I can't show you the top at the same time. Whoa. Oh. All right, well, I'm going to stop the video because my iPad just crashed. All right, we'll pick it back up in a minute. Well, let me see. Let me see if it's recovered here. Not sure what happened. I've never had the iPad do that. So we were looking up negative 1.07, okay? Negative 1.07. So it's going to be there. I can't make it too large because I'll lose the top. So negative 1. So negative 1 in here, and I need the 0.07. Okay, so come under this column right here, negative 1.07. I'm going to go blind looking this up. Okay, that's the one you want, negative 1.07. 0.1423. 0.1423. Okay, 0.1423. So that means 0.1423 or 14% above or below? Below. Remember, the number off the table is always below. Okay, I want above. I want to the right of that. So how do we do that? So above equals 100, all of it, minus the below, or 86%. Okay? All right. Okay. Let's stop this and we'll come back and we'll do video number 3. Hang in there. A lot of information, I know. See you in a minute.